Hi everyone! Welcome to part 2 of an introduction to trig ratios. Here's today's FLT. Given a right triangle with side lengths, I will be able to set up trig ratios by using the acronym SOHCAHTOA. So today we will be looking at how to set up trig ratios. Last time, we talked about how to identify different sides of right triangles. We have the hypotenuse, which is across from the right angle. We have the opposite side, which is across from where you're standing. And we have the adjacent side, which is right next to you. Remember that these sides depend on where you're standing. And so today, we are going to learn about 3 trigonometric or trig ratios. The first trig ratio is called sine. Our second trig ratio is called cosine. And our third trig ratio is called tangent. So sine, cosine, and tangent are trig functions which are often abbreviated in the following manner. The theta, right here, represents an unknown angle. So it's like a variable, like x or y, but for angles we use theta. So we read the symbol as theta, and theta represents an angle value. This bottom one, it looks like it just says tan theta, but we would actually read it as tangent of theta. So we have sine of theta, cosine of theta, and tangent of theta. Now, you'll learn more about these trig functions in future math classes. Today, I just wanted to introduce how to set up these trig ratios. So we're going to use this idea called SOHCAHTOA. Each letter actually represents a word. So SOHCAHTOA is an acronym that will help us remember trig ratios. S stands for sine, C stands for cosine, and T stands for tangent. Each H stands for hypotenuse. That's the side opposite of a right angle. O stands for opposite, so the opposite side. And lastly, what do you think A stands for? A stands for adjacent, so the adjacent side, the side right next to us. So we use this acronym, SOHCAHTOA, as a way to remember trig ratios. So let's say I have this right angle with angle theta. So I'm going to place my person at this angle right here. I will be standing at angle theta. We have the hypotenuse, which is across from the right angle. The opposite side, which is across from where we're standing. And the adjacent side, the side right next to us. The first 3 letters of SOHCAHTOA, so S-O-H, tell me that sine of theta equals the opposite side over the hypotenuse. So we can set up sine of theta by putting our opposite side over the hypotenuse. What does the second part of SOHCAHTOA tell us? This tells us that cosine of theta equals the adjacent side over the hypotenuse. And lastly, what about TOA? This tells us that tangent of theta equals the opposite side over the adjacent side. So SOHCAHTOA helps us remember trig ratios. So we have that sine of theta equals the opposite side over the hypotenuse. Cosine of theta equals the adjacent side over the hypotenuse. And tangent of theta equals the opposite side over the adjacent side. And theta represents the angle we are standing at. So let's use this idea of SOHCAHTOA in the upcoming examples. Please remember to draw the triangles in your notes as well. In example 1, we're going to find sine of A, cosine of A, and tangent of A. So we're focusing on trig ratios when we're standing at angle A. That's this angle right here. So I'm going to draw a person standing right here at angle A. I know that this side is my hypotenuse since it's across from the right angle. I also have the opposite side, which is across from where I'm standing, and the adjacent side. This is the side right next to where I'm standing. Using the idea of SOHCAHTOA, let's find the 3 different trig ratios. So I have my acronym SOHCAHTOA. Let's start off with finding sine of A. The acronym helps me remember that sine of A equals O, the opposite side, over H, the hypotenuse. In this case, our opposite side has a length of 4, and our hypotenuse has a length of 5. So sine of A equals 4 over 5, where 4 is the length of the opposite side and 5 is the length of the hypotenuse. So sine of A equals 4 over 5. Next, let's find cosine of A. Cosine of A is the adjacent side over the hypotenuse. Here, our adjacent side has a length of 3, and our hypotenuse has a length of 5. So cosine of A equals 3, which is the adjacent side, over 5, the hypotenuse. And lastly, let's find tangent of A. Tangent of A equals the opposite side over the adjacent side. The opposite side has a length of 4, and the adjacent side has a length of 3. So tangent of A equals 4 over 3, where 4 is the length of the opposite side, and 3 is the length of the adjacent side. So here we were able to set up the 3 trig ratios, sine of A, cosine of A, and tangent of A, by using the idea of SOHCAHTOA. For example 2, we're going to find sine of B, cosine of B, and tangent of B of this triangle. So we're going to be standing here at angle B. This side is my hypotenuse across from the right angle. This side will be the opposite side across from where I'm standing. And lastly, we have the adjacent side, the side right next to us. So again, let's use this idea of SOHCAHTOA to help us set up trig ratios. First, let's focus on sine of B. So sine of B equals the opposite side over the hypotenuse. Our opposite side has a length of 24, and the hypotenuse has a length of 51. So sine of B equals 24 over 51. Next, let's find cosine of B. Cosine of B equals the adjacent side over the hypotenuse. the adjacent side has a length of 45, and the hypotenuse has a length of 51. So cosine of b equals 45 over 51. And lastly, let's find tangent of b. Tangent of b will be the opposite side over the adjacent side. The opposite side has a length of 24, and the adjacent side has a length of 45. So tangent of b equals 24 over 45. So when you set up trig ratios, make sure you're standing at the correct angle. On Delta Math, you will simply be asked to set up one trig ratio per problem. Here, we're going to find cosine of A. Since we're finding cosine of angle A, we'll be standing here. Remember to correctly identify and label the hypotenuse as well as the opposite and adjacent sides. This is an important step to help you set up trig ratios. We're going to use the idea of SOHCAHTOA, but since we're just finding cosine of A, I'm going to focus on the second part, CAH. Cosine of A can be set up by putting the adjacent side over the hypotenuse. So the adjacent side over the hypotenuse. Our adjacent side has a length of 64, and our hypotenuse has a length of 80. Technically, you can simplify this, but for Delta Math, you can just leave this as is. So cosine of A equals 64 over 80. Up next, let's find tangent of B. So we're going to be standing at angle B right here. And first you want to label each side. So go ahead and identify your hypotenuse, the opposite side, and the adjacent side, and then press play when you're ready to compare answers. So hopefully you were able to correctly set up your triangle. We're going to use SOHCAHTOA to find tangent of B. So tangent of angle B is going to be O, the opposite side, over A, the adjacent side. Our opposite side has a length of 27, and our adjacent side has a length of 36. So tangent of B equals 27 over 36. Let's try one last example. Sometimes your triangle may be facing a different direction, but we still will use the same steps. So here we're going to find sine of angle A, which is this angle right here. So I'm standing right here, and although it looks a little confusing, remember the hypotenuse is always across from the right angle. So this is our hypotenuse. Our opposite side is across from where we're standing. So this side would be our opposite side. And lastly, the adjacent side is the side right next to us. SOHCAHTOA tells us that sine of A equals the opposite side over the hypotenuse. The opposite side has a length of 48, and the hypotenuse has a length of 50. So in this problem, sine of A equals 48 over 50. So today we learned how to set up trig ratios. Sine, cosine, and tangent are trig functions used with right triangles, and you'll learn more about them in future math courses. Remember the acronym SOHCAHTOA to help you set up trig ratios. S stands for sine, C for cosine, and T for tangent. A stands for the adjacent side, O for the opposite side, and lastly, H for the hypotenuse. Awesome job today, and please remember to submit your notes on Canvas. Thank you.